Welcome to Code Legends. If you're enjoying the content, please support the channel by subscribing and liking the video. Now, let's get started. Hey, and welcome back. In the last video, we talked a bit about how to communicate to the web server as a user and introduced a little bit about different types of databases. Today, we're going to talk about scaling. There exists a concept of two different types of scaling in system design: vertical and horizontal scaling. Vertical scaling, sometimes also referred to as scaling up, is the process of adding more power, such as CPU or RAM, to your servers. The CPU, also known as Central Processing Unit, is the brain of a computer that carries out instructions and performs calculations to make programs and tasks run. RAM, which is random access memory, is the computer's short-term memory used to temporarily store data and programs that the CPU is currently using so they can be accessed quickly. Horizontal scaling, also referred to as scaling out, allows you to scale by adding more servers into your pool of resources. When traffic is low, vertical scaling is a great option, and the simplicity of vertical scaling is its main advantage. Even though it's easy to set up, it unfortunately has some disadvantages, especially when we're talking about scale. Vertical scaling has a hard limit. It's impossible to add unlimited CPU and memory to a single server, and it does not have failover and redundancy. Failover means if one machine fails, another machine takes over without any downtime. And redundancy means having multiple copies of a resource so that if one goes down, others can handle the load. With vertical scaling, you only have one machine handling the work, and if that goes down or crashes, there's no backup to take over. If one server goes down, the website and the app goes down with it completely. Even though it's powerful, it's a single point of failure. Therefore, horizontal scaling is always the better approach for large-scale applications due to the limitations of vertical scaling. In the previous graph that we discussed in the lecture, we saw that our users were connected to the web server directly. Now, if something happens to this web server and it goes offline, our users are not going to be able to access our app. Or let's imagine if we have too many users that are trying to access the web server simultaneously and it reaches the web server's load limit, users are going to experience slower response or fail to connect to it at all. So now we should talk about a load balancer. This helps evenly distribute incoming traffic among web servers that are defined in a load-balanced set. Here, users connect to the public IP of the load balancer directly, and with this setup, web servers are unreachable directly by clients. In this case, clients are our users, web browsers, or mobile apps that they are using. Now, for better security, load balancers actually connect to private IPs, which are only reachable between the servers in the same network. When we say servers on the same network, we mean they are part of a private network where they share the same address space. Each server has a private IP that falls within the same subnet, and this subnet defines the network they belong to. They can talk to each other directly. Routers and switches inside that private network allow them to send data to each other without leaving the network, and they are isolated from the public internet. So only devices inside this network can reach these private IPs. So after a load balancer and a second web server are added to our graph, we are able to solve the failover issue we just mentioned and improve the availability of the web tier. For example, if server 1 goes down, all the traffic can be rerouted to server 2. This prevents the website from going offline. At this point, we can scale out and add one more web server to the server pool to balance the load. Another example, as mentioned, is if the website traffic grows super quickly and two servers are just not enough anymore to handle it, the load balancer can handle this problem, and you can just add more servers to the server pool, and the load balancer will automatically start sending requests to them. Now, seems like we solved the issue of the web tier, but what about the data? We can have same issues there because our current design only has one database, so what happens here? Here we can introduce the technique of database replication. Database replication can be used in many database management systems, usually with a master-slave relationship between the original, also known as master, and the copies, also known as slaves. A master database generally only supports write operations, and the reason is because it is the single source of truth for the data. We should make sure that our data is always consistent, and any changes such as inserts, updates, and deletes are made in one place to avoid conflicts. Also, performance is affected by this. By restricting write to the master, you can avoid the complexity of handling simultaneous writes across multiple databases. And then comes the data integrity part, where if no writes happen elsewhere, we ensure there is no corrupt data. A slave database gets copies of the data from the master database and only supports read operations. All the modifications of the data with inserts, deletes, or updates have to be sent to the master DB. In general, most apps require a much higher number of reads than writes. Therefore, the number of slave databases in a system is usually larger than the number of master databases. Now let's talk about some of the advantages of database replication. It offers us better performance because in the master-slave model, all writes and updates happen in master nodes, but read operations are distributed among the slave nodes. Therefore, we have an improvement in performance as it allows more queries to be processed in parallel. Also, reliability is another advantage. If one of your database servers is destroyed by a natural disaster, let's say, data is still preserved. You won't need to worry about data loss because data is replicated across multiple locations. And last but not the least, high availability. By replicating data across different locations, your app remains in operation even if a database is offline, as you can access data stored in another database server. This is all amazing, but now what if one of the DB goes offline? Here we come back to the same concept of load balancing. If only one slave database is available and it goes offline, read operations will be directed to the master database temporarily. As soon as we find the issue, a new slave database will replace the old one. There's also cases where you have multiple slave databases available, and in this case, read operations are actually going to be redirected to other healthy slave databases. And a new database server will just replace the old one. If the master database goes offline, a slave database will be promoted to be the new master. All the database operations will be temporarily executed on the new master DB. However, in production systems, promoting a new master is very complicated, as the data in the slave database might not be up to date. The missing data needs to be updated, usually by running data recovery scripts. Although some other replication methods like multi-masters and circular replication could help, those setups are way more complicated. This is a very hard concept, and we're not going to go into it right now. Now, let's quickly summarize what we talked about. User gets the IP address of the load balancer from DNS. They connect to the load balancer with this IP address. The HTTP request is routed to either server 1 or server 2. Web server reads user data from a slave database, and then web server routes any data modifying operations to the master database. This includes write, update, and delete operation. At this point, you have a solid understanding of the web and data tiers, and it is time to improve the load and response time. This can be done by adding a cache layer and shifting static content such as JavaScript CSS, image, or video files to the Content Delivery Network, or CDN. We're going to talk about caching in the next video. For now, thanks so much for watching, and I'll see you in the next one.